All right, everybody. I'm Ryan, and we continue CCNA with Packet Tracer 5413. A little bit more on access control lists. So if we look here at the requirements for a particular access control list, we want to control the traffic coming from these three PCs. And all the traffic for those three PCs goes through router 1, then to the internet. And look at the internet. No, it's not going to let us look at it. Later, when we do the ping, we can see the different parts of the internet. And right now we can successfully ping, or we should be able to successfully ping everything since nothing's getting blocked and routing's up. Let's try server 1 there. In fact, get that up. No. See the automatic pings. Open this thing up a little bit. So delete those. Click here. Go from there to there. You can see that we have connectivity. To limit type of traffic that can go there, we're going to block HTTP from this PC, block FTP from this PC, and block ICMP, or the ping, from PC3. And they give us the commands to do that, except we need to enter the initial command for starting the named access control list. And we're going to name the access control list ACL, which you asked me is a confusing name. It's like naming your dog Dog. You can do it. Everybody but the dog is going to be confused. All right, so we're in router 1. And do the enable. You can look at the running config real quick. Just see that we've got IP addresses there. We've got an IP address on Gigabit Ethernet 00, and we're gonna filter from the PCs. So we'll be using any of those, and we also have a routing protocol here. It's giving us all our routes, so we can ping everything. All right, but what we don't have is an access list. So let's make an access list. All right, so make a named access list. Named ACL. Oops, it's an extended access list. Go like that. And it gets us, you can see it gets us into this access list configuration mode. And the advantage here is going to be that the commands aren't going to be as long. And also they'll start, I like how they start the command with either deny or permit. So what we're going to do is we're going to just blacklist certain traffic, which means that we're going to deny certain traffic and then allow everything else. So the first thing it says it wants us to do is to deny HTTP and HTTPS traffic. So we'll do that. And we'll do that. Designating the port protocol is TCP. TCP is layer 4, so we will also have a port number assigned with it. 172.31.1.101 is PC1. And recall that with the host keyword, we're saying that it's just this IP address, not that whole network. And we're doing it to a single destination. So in this case, we're also going to do it to server 2. So, and since server 1 and server 2 are in the same, well, we don't really know if they're in the same network, but we could make a summary of the network and reduce the number of entries that we have here. But right now we're focused on denying traffic from one point to another point. So we have a single IP address here, which is PC1, to server 1, which is a single IP address there. If we wanted to verify that, we can go up to the table up here and we can see that PC1 is 172.31.101 and server 1 is 64.101.255.254. Just like we have here. Okay. So that'll do for our first access control list entry. The next one is going to be the same 2 destinations, but now it's HTTPS. So port number is 443. And then we want to do the same 2 protocols for server 2. And server 2 is, is it really 64.103? Just seems like since they can choose any IP address they want, they could make the numbers a little bit, no. There's only 2 servers, but they skip an IP address in there. Don't really know what their reasoning is for that, but it ends up being 103 instead of the more intuitive 102. With public IP addresses like that, you don't really get to choose normally. So maybe that's what they're trying to instill inside of you. All right, and then we're going to do the same 2 destinations, PC1 and server 2 for HTTPS. And then we move on. And you'll notice it's not complete. The completion thing isn't going up, and it probably won't until we finish the access list. But it's important that we do the access list exactly in this order, because packet tracer isn't, well, you could write scripts, I think, maybe for checking the stuff, but usually the easiest way is just to type in the commands that they're looking for, and in this case, you have to do it in the same order that they're looking for them in. All right, so now we're moving on to PC2. So our second PC right here. And we want to restrict FTP. FTP, remember, it's got 2 ports, one for control traffic and one for the data. Now you block one, it won't work. So that's what we're going to do. Deny TCP host, in this case, 72.31.1.102. Oh, probably could have copied the one from above. That's fine. 101, and then we do to server 1, 255.254. And since this is a layer 4 protocol, put in a port number. Okay. And we need to do the same thing for server 2. So the same source traffic, just a different destination. All right, and to get that, to copy like that, I'm hitting the up arrow. If I hit the down arrow, it'll just go away. So that'll do it for TCP. Now we're moving on to PC3. We'll do it the easy way this time. And PC3 is going to be 103. And it's going to be server 1 and server 2. We need to do server 1 first. And this is ICMP, which is a layer 3 protocol. And thus does not have a port number. All right. Let's just make sure we got the destination there. 101. Done. Okay. And then you do the same thing, but to server 2. Okay. So once we apply this access list, we try to ping from PC3 to that cloud or the server 1, then we shouldn't be able to make the connection. All right. So the most important part of this access list is to permit any other types of traffic. So if we do permit, do we have to do the IP? You have to do the protocol. All right. Permit IP any. I thought it might just let you type in any since we're defining all traffic, but apparently. And then once we put in the last line of the access list, notice the completion goes up to 80%. So we're almost there. All right. So we've got an access control list, but it's not doing anything because we haven't applied it to an interface yet. So let's figure out what interface we want to apply it to. So the traffic's coming from right here and going to over here. So with the extended access control list, we want to place them as close to the source as possible. Since the source and the destination are in there, we want to limit the distance that traffic goes through our network before we drop it. And it looks like the interface there is gigabit Ethernet 00. And if it's going from here to there, it's going to be in the inbound direction. So go to interface, gigabit Ethernet 00. And we do IP access group ACL, which is the name of the access control list, and we're gonna do it in the inbound direction. So maybe before we hit that return, we'll just do a quick little ping, just to show that, oh, I did the complex one, I don't want to do that. Let's do the simple one, server 2, and you can see that we're successful. Just in case you don't believe me there, we'll do it one more time. Server 1, and it's successful. All right, and then as soon as we apply the access list, it will instantly start blocking the traffic. So we can no longer ping from PC3 to server 1 or server 2. And maybe you can't really see that down there. You can see that we got a couple fails there. We'll do one more. Just to make sure. Sometimes it pretends like it's like ARP is working, and it'll deny the first ping because it's pretending that it doesn't have anything in the ARP cache. So we ping from PC1, you can see that we succeed. So we can get from PC1 and PC2 to the 2 servers via ICMP, but we're blocking the traffic coming from PC3. All right, so We've verified that last one, and it's always a good habit to do the copy run start the end of every configuration, just to make sure that it persists, especially after you verified it a little bit. So to verify that we're blocking web traffic, we know we have connectivity, but web traffic happens at a higher layer, so we need to actually get to the desktop and open a web browser. And then we put in server 1 or server 2, PC 1. In this case, 64.1.255.54. We try to get to the web server, says request timeout, which is what we expect because with this access list, we're blocking that traffic from PC 1. But if we go to PC 2 even, we hit the web browser. To the easy way, we can get to the web page on server 1. But if we wanted to do FTP on PC 2, FTP, it'll try and connect. This is these entries here. Sorry, I want to say FTP. So you notice also that it changed the number 21 to FTP. Those are the same things, but I guess Cisco does it this way because it's easier to understand for humans. All right, so we tried to connect to the FTP server and failed with PC2, which is what we'd expect would happen. But we do the same thing from PC3. We get it. So you can do username and password Cisco, and it'll log you on. But great. And you'll notice the completion rate here at the bottom is 100%. If you want to see the results, we could fun check results. And there's all our items. So good luck, and I'll be talking to you guys soon.